Hello, dear students. Welcome back to Farkh's website. My name is Masoud. I'm a physics teacher. So far, we solved and answered some questions of chapter review of chapter 1. We answered 33 questions, but in this lecture, in this lesson, I've prepared an extra question. Especially this question is is analogous. This question is analogous to the question, let's say 33, which is a question of national exam, right? I can say this question is a copy of question 33, except for one simple difference. In this question, question gives us a diameter. But in the previous lesson, I solved the question 33 in our textbook. It didn't give us diameter. It gave us radius directly. That's why I consider this question is a copy of the question 33, except for this difference. That's it, right? So the concept is the same. Let me read the question for you. It says a car traveling at 50.4 kilometers per hour. So kilometer per hour, you have to convert it to meter per second by means of a conversion ratio. I told you last lesson. This is the conversion ratio. Just multiply this number by 5/18 to convert the number into the meter per second, right? It says round the curve of diameter. So diameter means from edge to edge, from rim to rim. You have to divide it by 2. That's it. 400 meters means divided by 2 becomes 20 meters. So radius becomes 20 meters. Yeah, I mentioned it here. 20 meters. So let's keep going. Let's read the rest of the question. It says, find the minimum coefficient of static friction. What's the meaning of minimum coefficient of static friction? Means mu s. We look for mu s between the tires and the road that will allow the car to round the curve safely. I wrote a rule for you. Excuse me. I wrote a rule for you last lecture. I told you when the friction is in charge of keeping the object in a circular track, or in other words, when or if. Let me read it for you. Let me write it for you. If, look here, if Fs is equal to Fc, if friction is equal to, let's say, centripetal force, especially in this case, in the case of flat circular track, friction becomes a centripetal force for maintaining the car in a circular path, right? If Fs is equal to Fc, so mu s is equal to, look here, mu s is equal to AC over G. That's it. Maybe you say, teacher, AC is not present here. We don't have AC here. No problem. But we have another form of this rule. I want you to tell me the rule of AC. So change the form of the rule, actually. Write the value of AC. So I can say mu s is equal to, look here, mu s is equal to AC. Tell me the origin of AC. Where does AC come from? It comes from this equation, Vt squared over R, right? And we have G in the denominator. That's why mu s is equal to Vt squared over Rg. That's it. Maybe you say, teacher, where does this rule come from? You can start from here. If you forget the rule, you can prove it for you. It's like a simple proof for you, right? So Vt squared, where does this 14 come from? It comes from the conversion of kilometers per hour to meter per second by means of 5/18 by means of multiplying the number 50.4 by over 18 to get this number. So Vt is equal to 14 divided by R, 200. Maybe you say, teacher, why do you, let's say, put 200 here and in the question we have 400? But be careful. In question says diameter, it doesn't say radius. That's why you have to divide the radius, divide the diameter by 2 to get the radius. We deal with radius, not with diameter. That's why 200, let's say, works. 200 meter works. Multiply by 9.81, right? And the answer will be 0.1, and it's unitless. This is the question of national exam. That's it. Let's move on to another question, which is question 34. Let me read the question 34 for you. A 2 times 10 to the 3 kilogram car means 2,000 kilogram car, 2 tons. The mass of the car is 2 tons. Round the circular turn of radius to 20 meters. So this is the radius of the circular path, right? We have the radius of the circular path, 20 meters. This is R. If the road is flat and the coefficient of static friction between the tires and the road is, so mu s is given, 0.7. How fast? What's the meaning of how fast? Means we look for velocity, right? We look for speed. How fast means velocity, tangential velocity is unknown. How fast can the car go without skidding, without sliding, without skidding, actually? Mu s, we look for mu s. Let me jog your memory. We had the rule. I told you mu s is equal to AC over G. In which situation? If we have a condition here. If FC is equal to Fs. If friction becomes a centripetal force, so mu s is a ratio of two acceleration, AC over G. Right. So maybe you say, teacher, I don't have AC directly, no problem. I can write the value of AC in this equation. So mu s is equal to Vt squared over R, and we have G as well. Right now, what do we look for? It says, how fast can the car go without skidding? How fast? So you have to rearrange the rule for Vt. That's why Vt is squared, cross multiply the fraction. Vt is equal to Rg mu s under the square root. Why under the square root? Because Vt itself is squared. You have to put the value of AC under the square root. So that's it. Mu s is equal to 0.7, R is equal to 20, G is equal to 9.81, and you can find the answer, which is equal to 11.72 meters per second. That's it. Let's move on to question 35. A copper block, right? Let me read the question for you. A copper block rests 30 centimeters from the center of a steel turntable. 30 centimeters from the center. What does it mean? I'm sure you know, you are better than me in, let's say, imagination. It says a copper block rests from 30 centimeters, let's say, from the center of a steel turntable, from the center. So this is a steel block, for example, right? Copper block. The distance between the copper block and the copper block stands at this center, actually. It's located at the center of a circular track, and the distance between the copper block and the rim becomes 30 because the block, let's say, sits in a center exactly. From the center to the edge becomes radius. So R is given. This is R. from the center of the steel turntable, the coefficient of static friction means mu s, right? Coefficient of static friction means mu s between the block and the surface is 0.53. So this mu s, we have mu s. The turntable starts from rest. Omega initial becomes 0, right? And rotates with a constant angular acceleration of this number. This is alpha, 0.5 rad per second square. After what time interval? So what's unknown? After what time interval? So delta t is unknown. After what time interval will the block start to slip on the turntable, right? So we'll look for delta t. We have a hint here. Let me read the hint for you. The normal force in this case equals the weight of the block. So it says normal force Fn is equal to Fg, right? So in this situation, there are two, let's say, equation, and I can say this rule, this equation for the car traveling a circular track as well. You can let's say you can use these conditions. So there are two conditions. There are two conditions for the case of let's say friction. If friction becomes a centripetal force. Let me add this note for you. Let me write it here. If Fs is equal to Fc. I mentioned one condition for you. I said that the mu s becomes what? Becomes AC over G. This is a rule, right? We have one more condition here. If Fs is equal to Fc, so this condition leads to what? Leads to this condition. Fn becomes Fg. Means normal force becomes weight of the object. Fn becomes Fg. So if Fs becomes Fc, Fn becomes Fg, right? And I'm gonna draw a figure for you for better understanding. For example, there's a steel block or a car. We can use it for a car. I told you, for any object. Let's say if the friction is centripetal force, whether you have a steel block or a copper block or you have a, for example, car, no problem. If Fs, look here, if Fs becomes Fc, so this is Fs and Fc as well, right? This arrow becomes Fs and Fc as well. So here in this situation, let me draw other parts. What's this? This is normal force and this one is Fg. So in this situation, normal force becomes, less than normal force balances the weight of the car, and Fc becomes centripetal force. Fc becomes, or Fs becomes centripetal force. Centripetal force becomes frictional force. So we have two conditions. Fs becomes Fc plus what? And Fn becomes Fg. We have two conditions here. So anyway, and this information is true for the copper block as well, because here friction is, let's say, is in charge of maintaining the copper block in a circular track. That's why it's true for this question as well. So Vf is equal to, why do we say Vf? Because it says the object starts from rest. So Vf is equal to radical mu s Rg. Mu s is given, right? We have mu s 0.53. R, we have R 0.3. Actually, we have 30 centimeter. How do you convert centimeter into the meter? By dividing by 100, because 100 centimeter is equivalent to 1 meter. That's why whenever you divide 30 by 100, you get 0.3. This is meter, not centimeter, 0.3 meter. R is equal to 0.3 and G is equal to 9.81. So Vf is equal to 1.25 meter per second, firstly. Are we done? No, because it says after what time interval. We look for time interval, right? But we, let's say, we are close to the end of the question because we found, let's say, final velocity. But final velocity, you have to convert it to omega f. How do you convert tangential velocity to angular velocity, angular speed? By dividing this value by r. So Vf is omega f is equal to Vf by divided by r, 1.25 divided by 0.3 meters, and this is the answer, 4.17 rad per second squared. So we are about to finish. We are very close to the answer. One more step is left actually. Delta t is equal to omega f minus omega I divided by alpha, right? Delta t is equal to omega f. We already found omega f, 4.17, minus omega I is equal to 0, divided by alpha. Alpha becomes 0.5, and that's it. So the answer will be 8.34 seconds. That's it. This is about question 35. Let's move on to question 36. Right, question 36. Question 36 is opposite to the question of 33, 34, and 35. In question 33, 34, and 35, in these questions, F frictional force becomes centripetal force. Fs becomes Fc, right? But here, normal force becomes, let's say, centripetal force. Let me read the question for you. It says, in a popular amusement park ride, a cylinder of radius, we have a cylinder, there is a game, a cylinder of radius 3 meters. So the radius of the cylinder is how many meters? 3 meters. This is the radius, r is equal to 3 meters. Is set in motion. It's set in motion. It starts its motion at angular speed of 5 rad per second. So omega initial is equal to, let's say, 5 rad per second. As shown in the below figure, this is a participant. The participant enters the cylinder and he wants to, let's say, participate in this rule. It says, the floor then drops away. So this is the game. After the person enters the cylinder and the cylinder starts rotating, after a while, suddenly the, let's say, floor, I can say, drops away. If the floor is dropped away in this situation, leaving the rider or leaving the participant, let's say, in a circular track without falling, he or she doesn't fall because of what? Because of a centripetal force. Centripetal force remains it in a circular track. Teacher, which force becomes a centripetal force here? Is it friction between the, let's say, body of a person and the, let's say, cylinder? No. Friction does not, let's say, work here. Friction does not matter here, right? So which force is in charge of keeping the person in a circular track? Normal force. Reaction of the cylinder against the body of a person. This is called normal force. So, for example, this is a cylinder, right? This is a cylinder. And there's a person here, right? So reaction of the, let me draw it again. There's a cylinder and the person, let's say, is here, right? So reaction of the cylinder against the body of a person becomes a centripetal force. So what do we mean by reaction of the circular reaction of a cylinder against the body of a person means Fn. So here Fn becomes Fc. That's it. So the condition is completely different from the previous questions, right? Fc becomes Fn. But here Fs, teacher, what happens to the frictional force? Frictional force balances what? Balances weight of a person. So here we have two conditions here. Fc becomes Fn, means normal force becomes centripetal force, and Fs becomes Fg, means weight of a person balances the frictional force and vice versa. So anyway, it says it says what is, right? Let me read. Let me keep going the reading. It says the floor then drops away, leaving the riders suspended against the wall in a vertical position. So he or she does not fall. He remains in a circular track, even let's say even without the floor. Floor, let's say, drops away without falling the person. What minimum coefficient of static friction between the rider's clothing and the wall of the cylinder is needed to keep the rider from slipping? So what do we look for? We look for coefficient of static friction, mu s, right? I wrote a rule for question 33, 34, 35. If you invert the rule, this rule becomes a rule for 36. So I said that in previous lectures for question 33, 34, 35, I wrote a rule for you actually. I read it for you. In these questions, in previous questions, we said that, look here, we said that mu s becomes what? Becomes, let's say, AC over AG, if you remember. But here you have to invert it, right? In question 33, this rule does not work. This rule doesn't work for question 36. You have to invert it. How do you invert it? G becomes the numerator. G goes to the numerator, and AC goes down. So mu s becomes what? Look here. Let me prove it for you. Mu s becomes G over AC. Right. Right. So G is equal, and I can say G over AC. I want you to think about the value of AC. AC is equal VT squared over R. But here, because we don't have VT, think about the role of AC in terms of omega and R, in terms of angular speed and R. Let's say AC becomes what? Let me jog your memory. AC becomes, let's say, R omega squared. You see? If you substitute the value of AC here, you can use this rule for question 36. So this rule works here. I want you to memorize this rule. This one works for question 36. G over R omega squared. G 9.81 divided by 3 multiplied by 5 squared, because 3 means the radius of a cylinder, and 5 is omega of the or angular speed. We've already, let's say, had it right within the question, and this is the answer, 0.131 without any unit, because it's unitless, right? So let me read some notes for you about question 33, 34, 35. Some of these questions are questions of national exam. That's why, let's say, they are important and they are easy. I want you to memorize the rule. These notes are appropriate for you. They are beneficial for understanding the subject, let's say, in a good way. Tip number 1, in question 33, 34, and 35, Fc becomes Fs. What does it mean? It means centripetal force becomes frictional force. where Fc is centripetal force and Fs is frictional force. So either, look here, either mu s becomes AC over G, or mu s becomes Vt square over G, or mu s becomes R omega square over G. So there are three rules for finding mu s for question number 33, 34, and 35. Right, but this is the original rule, AC over G. Right. Let me add one more, let's say, equation here. I'm gonna add one more thing here. I say in question 33, 34, 35. Question 33, it's about the car. 33 and 34. 35, it's about a copper, let's say copper block. Right? For these questions, friction is in charge of keeping the object in a circular track. That's why in this situation, Fs, look here, Fs becomes Fc, and one more condition, I'm gonna add it here. I can say Fn becomes Fg. Normal force balances the weight of an object. Tip number 2, only in question 36, look here, only in question 36, right? Fc is equal to Fn. Only in this question of cylinder in a game, in a, let's say, amusement park, right? I can say only in this question of game, Fc is equal to Fn. Normal force becomes centripetal force. Fc is centripetal force, and Fn is normal force. And you know, normal force means reaction of a wall against the body of a person. Either mu s is equal to, look here, G over AC. So what's the relationship between this mu s and the mu s in the question 33, 34, 35? It's completely opposite, right? If you invert the rule of 33, 34, 35, it becomes the rule for question 36, question of cylinder, right? Or you can say mu s is equal to Rg over Vt square, or is equal to mu s equal G over R omega square, based on the given of the question. Actually, sometimes, let's say, given tells you which rule is convenient. Sometimes person, let's say, chooses a rule based on the given of the question. Actually, you can find the mu s or other factors. Thank you so much, guys, for watching this video, and bye bye.